Hey everyone, this is Daniel for Rock the JVM, and you are watching a long-form tutorial on functional and idiomatic error handling in Kotlin. Specifically in this video, we're going to talk about result and either. So for this tutorial, I'm only going to assume that you know some essential Kotlin so that you can follow along. And as always, I recommend that you write code with me to make the best out of this video. And whenever you need to refresh your memory about these concepts, just refer back to this video or to the written form at the blog with the link in the description. This is a follow-up to another long-form tutorial that I made not too long ago about dealing with absent values in an idiomatic way with Kotlin and the Arrow functional programming library. We're going to do a very similar thing here with result and either. So without further ado, I'm going to get back to my development environment. And in my little object here with a little main method, just so in case that we need to test some stuff, I have a data class called job to simulate a little jobs board for this tutorial. So we're going to simulate a use case for a jobs board that are going to filter jobs and are going to display various stats about job postings in our fictitious application. So I have a data class called job with a job ID, a company, role, and salary, each of which are value classes so that we have zero cost boxing over primitive types or standard types on the JVM. All right, so I have job ID, company, role, salary. These are very simple data classes. If you want to pause the video to type them in your own project, just feel free. You can also find them at the beginning of the article, and you can find a link to that in the description as well. Okay, now let me simulate a small jobs database. And this is going to be a map of job ID to job, and I'm going to create a map of, and I'm going to create some associations. For example, job ID 1 to a job with the following details. Job ID 1. Let's have a company. So we have a company, let's say Apple, and then we have a role, let's say software engineer, and we also have a salary for, let's say, $100,000. Okay, cool. Now this is a double. I'm going to create the appropriate double here. Okay, let me copy this, and I'm going to have a bunch more, and I'm going to have, let's say, a Microsoft and a Google or something like that. So I'm going to have job ID 2, let's have a Microsoft, and then we have software engineer. Let's change this to 100,001, and then a Google, let's say SRE for site reliability engineer. Let's change this to 100,002 or something like that. Okay, so we have job ID 1, 2, 3. Okay, so we have our little fictitious job database, which we can then process. Okay, let's create a little interface. So I'm going to create an interface called jobs, and I'm going to simulate some functionalities on these jobs by treating various kinds of errors, and I'm going to walk you through step by step. Now, in the last video where we dealt with nullables and options, we dealt with the potential absence of a value. Now, in this case, in this tutorial, we're going to deal with potentially failed computations. That is, those computations which on normal JVM applications would throw an exception. Now, idiomatically in Kotlin, we don't really use try catches that much, but rather we use a data type that embodies the potential computation that can fail. So that type is called result. Let me show you an example of that. I'm going to create an Apple job result as a result of type job. And this is a data type that can either contain a job or a potential exception in case this computation failed. I'm going to show you a success or a failure. I'm going to say result.success, and then you can pass a pure value in here. So we have a job with job ID 2 or something like that. So we have Apple job, so I'm going to copy the job details for Apple. All right. So result.success is a kind of result that stores a pure value of type job. So we know for a fact that this computation was successful, that did not throw an exception. Let me show you a result which, quote unquote, threw an exception, but we, rather than throwing an exception, we stored that exception as a value so that we can process it later, so that we can potentially recover from it. So let's say we have a not found job, again, as a result of type job. And I'm going to use result.failure. And the failure constructor takes an exception as a throwable. So we have no such element exception with, let's say, job not found. So you know how to build a success or a failure. So the next time that you create some sort of functionality that tries to search for a job in the database and you would want to potentially recover from a exception from that database, rather than doing a try catch, you should use results. And I'm going to show you how throughout this tutorial. Okay, now we don't really have some extension functions on this result so that we can process them easily. So I'm going to create my own. So I'm going to have a fun I'm going to say t.toResult, and I'm going to return a result t. So notice that we can use extension functions very easily. I'm going to say if this is throwable, I'm going to have result failure this, else result success with a capital R. So result success this. So we can use this toResult thing to say val result as, let's say, Apple job, such as this data structure. I'm going to select it. So I'm going to say job.toResult so that we can treat this value as a result data type, which we can process later. So this is very easy for us in Kotlin to create extension functions. Okay. Now, I have my interface that I created earlier. I'm going to separate it with some comments. So I'm going to have a little separation here so I can identify it easily. And this interface jobs, let's say we have a function called find by ID with ID as a job ID. So this is going to be kind of like a repository where we can find a job ID. And we now know how to return a job. We're not going to return a job with a question mark. We're not going to return an option job, but we're going to return a result of job question mark, which means that we might fail. So we might fail to find by ID for some exceptions. And if we do have a successful computation, we might return a job or we might return nothing. So this is going to be our interface. Now, I'm going to create a little class. Let's say live jobs that extends jobs. And I'm going to put that right below the interface so that we can find both of them easily. And this live jobs will have an override find by ID. And let's initially run a try catch. So I'm going to say try, and I'm going to return result success with jobs database at this ID. And I'm going to catch any sort of exception, exception, and I'm going to return a result failure with this E that I am going to return. So notice that in this case, we're kind of mixing the old try-catch style with this new result data type. You'll find that this is not necessarily the most idiomatic way, at least not in this very explicit style, but rather we can try to hide the try-catch stuff by using some built-in functions from Kotlin. So for example, we have something called run catching in Kotlin. So I'm going to comment this out, and I'm going to show you how we can implement a very similar functionality with, say, run catching. So run catching is a very nice function built into Kotlin that will try to return job database on this ID. And this run catching basically runs the exact same function that we commented out. So we are going to return a try catch, but this reads a little bit better. So we have run catching jobs database ID. This is our desired value. And any exception that might be caught in this code block will be caught, and it will be returned as a result failure. Now, once you have a result job, you can actually process it differently. For example, you can check for success or failure. So you can have, let's say, is result success as result dot is success or is failure. So you can check both. And you can also extract the value inside this result by providing an alternative. So for example, you can say get or null, get or throw, get or default, get or else with your additional functionality here. Let me show you an example. So in our little fictitious jobs application, I'm going to create a class, let's say job service. With a plain old dependency injection, I'm going to create a private val jobs. And I'm going to have a little function. I'm going to have a function, let's say maybe print job at a job ID. Okay, let me use this jobs repository to find it. So I'm going to have val, let's say maybe job, which is a result with job question mark as jobs find by defined by ID on this job ID that I have as argument. And I can check, for example, if this result is a success or a failure. So if maybe job is success, then I'm going to say maybe job get or null, and this is going to be a job question mark, and then I'm going to have my little Elvis operator to say apply, for example, and I'm going to have my print line with job found, and I'm going to inject this, which this is going to be inside the scope of apply. So this is going to be my actual job, and I'm going to use the Elvis operator, and if we cannot find it, then I'm going to have print line job not found. Okay, and else, which means that this maybe job is a failure, I'm going to say print line something went wrong, and I'm going to inject some sort of expression, and you can say maybe job dot, and you can also check for the exception rather than the value, so you can say exception or null if you want to extract the exception and do something with it, maybe. So you can say treat the exception, maybe log it, maybe submit a crash report or something like that. Okay, let me try to test this. So I have my little job service, and I'm going to have my jobs as live jobs, and I'm going to have my job service as job service with this jobs. And then let me say job service print, or maybe print job with job ID number 2. So let me run this application, and we should see an existing job, which in our case, I think it's the Apple job. So we have job ID number 2, and we should have job found, and that's going to be the Apple job, job number 2 with Apple software engineer, and so on and so forth. We have Microsoft. Was that Microsoft? Microsoft. Okay. So it's the right job for job ID number 2. If we have a different job ID, for example, a job ID 42 instead of 2, okay, we have nothing being printed out, and that's because I did the print line in a function rather than a plain expression. So we should be seeing job not found here. Let's see. Okay, so we have job not found. Cool. So now you know how to treat results for successes or failures. You can also extract their values up with get or null, get or else, and or exception or null if you want to extract the exception instead. So there are a bunch of functions built into results that you can run directly. Okay, so we have get or null, get or else, and so on and so forth. Now, far more idiomatic with these results is to transform them for later computations. For example, if you want to do some sort of statistics on this particular job, maybe you want to extract the job's salary. If you want to extract the job's salary, you'll have no choice, at least at this point, to check whether the result is a success, and if so, you'll say get or null, and if it's null, then you'll return something, and if it's not null, then you'll try to return that job's salary, which is a multi-stage computation. But far more idiomatic is to do map, for instance. Map transforms a result to another kind of result. For example, if I have my little Apple job result, you can extract this Apple job result salary as a result of double in this case by mapping it. So for example, I'm going to say Apple job salary as Apple job result map, and then you can pass a function from the job inside to something else. So I'm going to say it.salary, for instance. It is going to be the argument of the function of the lambda that this block represents. And the salary is going to be the field of that particular job. And this is going to be a result of, where's that? We have result of salary in this case. So notice that you can also change the type of that result by mapping it to some function of your choosing. You can also use map catching if the transformation that you want to apply can also potentially throw an exception. So results have that built in. So I can say Apple salary catching as Apple job result. You can say map catching, and you can say it's salary, but this function is also guarded against potential exceptions. So if this thing fails, then this result will contain the failure thrown by this potential function. So let me show you an example of how we would do that in our fictitious application. So we have jobs, live jobs, job service. Let's also create a little class. I'm going to call this currency converter. And I'm going to have a function, let's say convert USD to euros. I'm in Europe, so this kind of stuff happens very often. I'm going to have an amount called double with a question mark, and this returns a double without a question mark. And I'm going to say if the amount is not null and the amount is bigger, the amount is bigger than 0.0, I'm going to return amount times 0.91, I think the currency rate conversion is at the time of recording. Otherwise, I'm going to throw illegal argument exception. Let's say amount must be present and positive. There's no such thing as negative money. By the way, never use double for money because doubles lose precision if you want to do mathematical operations on them. If you want to use money, then you'll probably need a specialized library for doing that. Okay, so currency converter. Okay, let me show you how we can use this currency converter with map catching. So in my jobs service, I'm going to create another function. Let's say get salary in euros for a particular job ID. So notice that we have multi-stages in this case because we need to find the job, and if so, we are going to convert its currency to euros given the fact that we have a currency converter, which by the way, we need to pass as argument. So I'm going to have a currency converter. Okay, so get salary in euros. Now, this is going to be a result of type double, and I'm going to say jobs find by ID with this job ID. Then I'm going to say map with it salary. So I'm going to use the question mark because in this case, the job that I'm going to return is potentially null. So I'm going to say it.salary. And I'm going to have map catching with currency converter, which I need to pass as a value here because otherwise I can't see it. So currency converter, convert USD to euros, it underscore dot value. You know about the it underscore dot, this kind of operator we used in the previous video when we dealt with nullables. So notice how easy it is and how readable and how compact the code becomes by doing all these chained computations, like find by ID, then transform it and return its potential salary. And then we're going to run a map catching with a function that might throw an exception, and that exception is swallowed and stored very nicely in the final result. So every single step here along the way can fail, and this result will neatly store the exception that first occurred, which will break the computation chain as intended. So for example, let's try to run a currency converter. So I'm going to have my currency converter as currency converter. I'm going to pass this as argument, so currency converter. And instead of printing the job, I'm going to return the salary. So I'm going to say maybe salary as job service, get salary in euro for job ID 42. And then I'm going to say print line, maybe salary. Let's run this. All right, so we have a failure with a legal argument exception. Amount must be present and positive. That is because the job 42 could not be found. If I have job number 2, then we should have a success. All right, so we have a success with 91,000.91, and that's going to be the euro equivalent of $100,000. All right, so I would argue that this style of writing code to find by ID, then transform it with a computation that might fail, is far more readable and understandable at a glance than the very defensive style that we used to do with try catches and null checking. Now, the downside of this is that you kind of lose control over the exceptions that might occur along the way, but the result type gives you the opportunity to recover from these exceptions and try to deal with them in a very specialized way. Let me show you how you can do that. For example, here in maybe salary, I can say val recovered as maybe salary dot recover. And here in this recover function, you can return a default value in case you get any sort of error. And you can treat every exception separately. So for example, I'm going to say when it, and the it is the exception type. So when it is illegal argument exception, then you can treat it in a particular way. So I can say print line amount must be positive. And then I'm going to say else, I'm going to say print line some other error occurred. And I'm going to say it message, for example. So you can treat every exception specifically, and then you can return a default value. You can also return a default value inside the when expression. I'm going to return 0.0 because this little thing is applicable for any exception, but you can return different values for different exception types, which makes it pretty powerful. So I'm going to print this recovered instead, and we're going to see one of these exception messages. So we have Java-lang, illegal argument exception. I have some conflicting imports. Okay, so we have a success with 91,091. Well, in this case, that is true because we have job ID for ID number 2. But if we have an ID that doesn't exist, we should be seeing one of these error messages. All right, so we have amount must be positive, and in the end, we returned success with 0.0. I clicked the wrong button here. So we have a success with 0.0, which means that you can recover from any of those exceptions that you see fit. And also the most general way of treating a result type, both for success and for failure in the same call, is called fold. So this is a way that you can do recovering, so recover from error. And fold is another construct that will allow you to return an expression based on the value that the result contains, or a value based on the treatment of potential exceptions. So for example, in this case, I'm going to say final statement as, say, maybe salary dot fold. And fold has two functions, on success and on failure. So I'm going to have fold with a function that says, let's say, the salary of the job is it, which is the argument to the double. And the second value is going to be a function from a throwable, and I'm going to have this when expression along with 0.0. And I'm going to have, let's say, a string with a job not found. So we have 0.0, something like that. So notice that in this case, we also have the type of the final expression changed. So in this case, we're going to have a final string that we can return from this result type because we've treated both cases, both the success and the failure. And in both of these cases, we returned a string. So I'm going to also say print line with final statement, and we're going to say job not found, so we have 0.0 because we're dealing with the value 42. Okay, so we have amount must be positive. That's because we also have side effects in this treatment of the error case. So we have success 0.0 and job not found, so we have 0.0. All right. Now the next thing that I wanted to show you is how to compose result instances. Let me show you some examples. So for example, in this jobs interface, I'm going to create a function to find all with no arguments. I'm going to return a result of list job. And I would like to create a function that returns a gap between the salary of a job that I pass as argument under a job ID and the average of all these jobs. So I would like to first implement this find all thing. So I'm going to have my override find all, and I'm going to have a single expression here, result, success, and I'm going to say jobs database values to list or something like that. Values is a value, so to list, like that. Okay, so we have a result doc success. Cool. Now, I would like to create an extension function that on a list of job, I'm going to return a average salary, or let's say a max salary. So right underneath the currency converter, I'm going to create an extension function. I'm going to have my function list job, max salary, for instance, and I'm going to return a result of salary. And I'm going to return a run catching, because I now know how to use it. We saw this earlier. I'm going to say if this is empty and this is the list of job. And I'm going to throw new no such element exception. So let's say no jobs present or something like that. Else, I'm going to say this max by, and the function that I'm going to return here is it salary value, because that's going to be a double. And then I'm going to return salary because this whole expression until the dot is going to be a single job. And then I'm going to return the salary of that. So I'm going to return the max salary. Okay. Now, in my jobs service, I'm going to create a little function that returns a salary gap between the job defined by a job ID and the max salary inside the entire database. So I'm going to have my function, let's say get salary gap versus max or something like that. And I'm going to have my job ID as job ID. And this is going to be a result of type double. Okay, I'm going to run a run catching. And the step-by-step way of doing that would be first to find the job by this job ID. Then I'm going to return the job ID's salary or 0 if that thing doesn't exist. So I'm going to have maybe job as a job question mark as jobs find by ID on this job ID. And I'm going to say get or throw. Because I'm in a run catching, I get to throw an exception. And I'm going to have my val job salary as maybe job dot, I'm going to have a question mark dot salary with the Elvis operator. I'm going to say salary with 0.0. So step by step. Then I'm going to have my job list as jobs find all. And I'm going to go get or throw again. And in this case, I'm going to have my max salary as salary, and this is going to be my job list max salary because we have the extension function, again, get or throw, because that also is a result. So notice that in this case, in this block, we're dealing with plain values. And finally, I'm going to return max salary dot value minus job salary dot value. So this is the plain step-by-step imperative way of dealing with such values. So we're combining two results by basically extracting their values inside and then doing some sort of computation with them. This is the non-idiomatic way. So I'm going to call this non-idiomatic. Why is this non-idiomatic? Because we're manipulating the values inside these results manually ourselves step by step, rather than dealing with the results as regular data structures and manipulating them at a higher level. Let me show you how we can do that in a more idiomatic way. So I'm going to have my fun get salary gap versus max, and this is going to be my idiomatic way. I'm going to have my job ID as job ID, and this is going to be a result of type double. I'm not going to do a run catching this time because we already have result of type job, of type salary, and so on and so forth from the other calls that we wrote so far. So I'm going to say jobs find by ID first. So job ID. This is going to be a result of potential job. Now, in order for me to transform this result, I can transform it with map, which you already know. But because the function that I would like to do, which is to find its salary and combine it with the maximum of the rest of the jobs, that thing returns another result, which in this case will return a result of something. That nested data structure can be flattened with a flat map instead. So I'm going to say flat map. Now, in order for me to do flat map, we can use that as an extension function with the arrow library. Now, what on earth just happened on my screen? I'm going to import arrow core, and I'm going to import everything. So including the extension methods. Okay, so I have flat map. Notice that the compiler noticed that we now have a job now. I'm going to call this maybe job. Cool. Now on the maybe job, I'm going to return its salary. So val salary as maybe job, question mark, salary, Elvis, and then we have salary 0.0 if we don't have it. Okay. Now, I'm going to return a result of something because the flat map function takes a function from job, question mark, to result of something else. Now, in my case, I need to return that particular result of something else, which is jobs find all. This is going to be another result of list of job. And then I'm going to flat map that too. So I'm going to say flat map. In this case, I have a job list. And then I'm going to return its max salary. So I'm going to say job list max salary map. And given the max salary inside, I'm going to return the difference between max salary dot value minus job salary. Where's that? The job salary value. This style is more functionally pure in the sense that you can treat those results at a very high level without having to deal with potential errors yourself. You simply chain them with flat map and map chains. Now, because Kotlin doesn't have support for monadic comprehensions, in Scala those are for comprehensions. So in Scala you would do something like a for comprehension, and you would have something like job in jobs find by ID, then you have salary as job salary question mark and so on and so forth. Then we have job list as jobs find all, and then you'd have my max salary as job list max salary, and then you'll yield max salary minus salary. So this would be the standard way of dealing with such a thing in Scala with the either or try types. So notice how easy it is to read such a thing. You find by ID, compute the salary, find all, turn the max salary, and then finally just return this expression that you were looking for. So it's very easy to read all these computations in a chain. But Kotlin doesn't have support for built-in for comprehensions or monadic comprehensions, which is why the Arrow functional programming library gives us access to something that looks similar to this, but with a more complex construct. So I'm going to show you what the Arrow library does. Now, for that, I'm going to go at the top and import arrow core continuations star. Okay. Now, arrow core continuation star. Now, with arrow core continuation star, we can write a very fancy DSL, which is result.eager, which in its scope has something that looks very imperative like this. So I'm going to have my fun, let's say get salary gap versus max. I'm going to call this arrow or something like that with job ID as job ID. And this again says result double. Okay, now I'm going to say result.eager. Now, in this case, I have a variable that I called result, which I'm going to rename because result is something that is built into the arrow library. So make sure you rename or name the variables correctly so that you don't have naming conflicts. So result.eager. Now, inside this result.eager, we have a result eager effect scope, which is kind of like a fancy thing. I'm not going to talk about how this thing works in detail. The blog post gives more details if you want to check that out. But essentially, inside this eager scope, I can run a very imperative kind of computations where for every result, I call a bind function. Let me show you how you can do that. So for example, I have a maybe job, which is a job question mark as jobs find by ID on this job ID. So right now we have a job question mark, but then I also call a bind function on this. Essentially what this does is if it throws some exception, then break the chain, which in this case, interrupt the computation here and return the exception inside the result at the end of the function. But at the end of the computation, I have a job question mark, which means that I can use it later. So I'm going to have my val salary as the exact same thing that we used to have, which is maybe job salary or salary 0.0. So you can do that like this. But I'm also going to show you a different kind of technique. For example, I can show you ensure not null. Ensure not null is something that you can run inside this result eager effect scope. And I'm going to say ensure not null on the maybe job. So maybe job. And if it is null, then I'm going to throw an exception. So I'm going to say no such element exception with say job not found. Again, because this exception is being thrown in this result eager effect scope, it will break the rest of the computation, which is intentional. Now, in this case, after I've done ensure not null, I know for a fact that maybe job is not null. So I can use it as a plain value. So I'm going to say val job salary as maybe job dot salary. So notice that the null is eliminated by the compiler. So we have a very primitive form of float typing due to the usage of this ensured not null. Okay, then I'm going to have my job list as jobs find all, then I'm going to call bind. So you need to remember to call bind on your results. And then I'm going to have my max salary as job list max salary bind. And then I'm going to return max salary value minus job salary value. So a very imperative style. All right, so at the end, we simply return a plain value, and that will be stored in the result. And the rest of the stuff, all the bind functions, will take care of the potential exceptions. We'll store that potential exception in the final result if that happens, and it will interrupt the rest of the chain. So this result.eager is a very complex construct, but that will allow you to run otherwise imperative style of writing code. So both getSalaryGap versus max and this one with the result.eager have the property that if you get an exception along the way, the rest of the computation is short-circuited. Let me show you how this will run in main. So here I have recovered. I'm going to also print line salary gap or something like that. And then I'm going to say val salary gap as job service. And then I'm going to say get salary gap versus max on job ID 42. And then I'm going to also have salary gap, say version 2 as salary gap versus max arrow with job ID 42. And then I'm going to fold them both. So let me do salary gap, fold, and I'm going to have a print line. Let's say salary gap, and I'm going to inject it. And in case we get an exception, I'm also going to print line error, it. And I'm going to do the exact same thing with salary gap and salary gap version 2. So salary gap version 2.fold. Now, there is a functional difference between salary gap and salary gap version 2 in the sense that the first salary gap with the flat maps, we have a default value of 0.0 if the maybe job is empty. Whereas in this case, we have a short circuiting, no such element exception in this case because we have the job not found. So the results are actually going to be different if we compile and run this code. So we're going to have a salary gap of 100,000 something. So we have salary gap of 100,002. And in the case of salary gap version 2, we have no such element exception, job not found. So I hope that makes sense. Now, one thing to be very careful with in the case of this result eager stuff is that you should always try to work with plain values, in this case, the values stored inside the results by calling bind, but never throw exceptions inside something like this because exceptions will not be caught in the final result and they will bubble to the caller. For example, if I do throw, let's say, runtime exception with boom, this thing will not be caught. So notice that the compiler also catches that because we have unreachable code after that. If I run this computation, you'll see that the exception will be stored as an actual error in your application. So the boom thing will not be caught by the result. So make sure never to throw the exceptions themselves, but always to catch them inside results, inside this result eager DSL. Okay, now at this point, let me show you the either type. The either type also stores a potentially failed computation, but the failure is not a throwable, the JVM throwable, but rather any sort of thing, so any type, that means an exception to you. It can be a string, it can be a code as an integer, it can be your own data structures, it can be anything at all. Now, let me take this comment out because I would like to have my code nice and structured. And I'm going to have my either type here because I'm going to show you how we can build either types initially before we can insert additional functionality to our little fictitious jobs platform. Okay, now for the either type, we'll need some error modeling. So for example, at the top in the interface jobs, I'm going to create a sealed interface. I'm going to call this job error, and I'm going to have my data class. I'm going to say job not found error with a val job ID as a job ID, and this extends job error. And I'm going to have another data class. I'm going to call this generic error. Generic error. And I'm going to have my val, let's say cause, as a string. And this extends job error as well. Okay, so we have a sealed interface. This is going to be our custom error data type. So notice that this does not inherit from the throwable hierarchy as is usual with the JVM. So for the either type, I'm going to have, let's say, Apple job either as the type either with job error on the left. This is the undesirable value, the error type, and the desired value is on the right as a job. And you can build a left with a job error or a right with a job. For example, I can build a right with a jobs database applied to the job ID number 1, if I remember correctly, and I'm going to force that to not be null. So I'm going to import either from error core. So I have either.right. Okay. Now the ID 1 is actually job ID with 1 because you cannot really use ints instead of job IDs. So this is how you can build an either. You can also build either.left with a job error instead. Obviously, you can check whether an either is a success or a failure. So check is left or is right, just like is success or is failure for the result data type. You also have extension functions. Just like we had to result, the kind of stuff that we wrote it, Arrow provides left and right extension functions for regular values. So I'm going to have Apple job either. I'm going to have version 2 here. Instead of doing either.right, I'm going to say jobs database job ID 1, forcing not null, and I'm going to say right, like this. So right and left are extension functions. You can also say get or else, get or null, and so on and so forth. There are various get methods on the either data type, just as we had for the result data type. And also we have map, flat map, which means that we can also have functional ways of processing these either data types, just like we did with results. And we also have an either scope, which allows us to work with potentially failed computations that are typed with our desired error types in just the same style as we did with results. I'm going to show you. So let's go to our interface jobs all the way to the top, and I'm going to create a different function. I'm going to say find by ID with an E at the end, with an ID as a job ID, and I'm going to return an either with job error or job. Now let me go implement that. So I'm going to go in my live jobs implementation. I'm going to have an override find by ID E, and I'm going to have a try catch, for instance. So I'm going to say, let me remove that. I'm going to say try with jobs database invoked on the ID. Then I'm going to say right. And if this thing does not exist, then I'm going to have a job not found error with ID. And then I'm going to say left. And catch, if we have a exception, then I'm going to have a generic error. So I'm going to have generic error with E message. And if that thing doesn't exist, I'm going to say unknown error. And then I'm going to wrap that into a left. So notice how handy these extension methods are. Now this pattern is so common, just as it was with result, that Arrow provides a function that is very similar to run catching for result. And that thing is simply called catch. So I'm going to say either catch. And either.catch will allow you to essentially catch any sort of non-fatal exceptions. And if you catch non-fatal exceptions, you're going to return a left. And inside the either.catch, you can simply process your own values as you see fit. And by default, those will be a right. In our case, will be jobs database applied to ID. And obviously, jobs database on a non-existent ID will throw a no such element exception. And if that we're going to have map left, so you can map both the value, the desired value, and the undesirable value with map left. And in case we have a map left with a throwable that we do not understand, we're going to return a generic error. So I'm going to say generic error with it message. And then if this it message doesn't exist, I'm going to say unknown error. So we're going to process the left side to return a different kind of left side, which is, in our case, generic error. And then I'm going to do flat map. And in case we have a maybe job, I'm going to say maybe job, question mark, right. So I'm going to return a right value. And if this thing doesn't exist, then I'm going to have a job not found error with ID, and then I'm going to return a left. So for any exceptions that might occur by accessing jobs database, I'm going to transform that error into a generic error. So that throwable will be turned into generic error, which is my desired type. And if we have a potential value called maybe job, which is a nullable thing, then I'm going to treat it manually myself. If this thing is not null, then I'm going to return a right on that particular job. If it is null, I'm going to return an error of my choosing. So this is the more idiomatic way to find by ID with the either data type. Now, if you followed along this far, first of all, thank you for following along so far. Second of all, I think you should get at least a rough picture of how to think about these wrapper data types. So after the result data type, you got a pretty good idea of how to transform result data types with map and flat map and catching and the result eager scope. We're going to follow similar examples with the either data type now. So we're going to replicate the same example where in the jobs service, we're going to return the gap, the salary gap versus max, given a job ID, and with the either return type instead. So I'm going to go to my jobs interface, and I'm going to replicate the find all function by saying find all E, and this is going to be an either of type job error on the left and job on or list of job on the right. And in my live jobs implementation, I'm going to return my override find all E, and I'm going to return jobs database values to list, and then I'm going to wrap that in a right. That's it. Cool, so we have find all with either. Now, in my jobs service, I'm going to show you how we can do same function, salary gap versus max with the either type. Right, now for the either type, we also have these flat map chains, which we can also replicate with eithers as well. So I'm going to define a function, let's say get salary gap versus max, and I'm going to have a suffix E here, so job ID, and this is going to be an either of job error or a double on the right if we have a desired value. Okay. How are we going to do that? Well, we're going to essentially replicate the exact same concept. So I'm going to have jobs find by ID E, so with the either. Then I'm going to flat map. Then if I have a maybe job, then I'm going to return its salary. Then I'm going to say find all E with the either type, then flat map. Job list. Then I'm going to say job list max salary. Now, max salary is going to be a result. So I'm going to define a max salary E with either. So let me go. Where do I have the extension function? So I have max salary. I'm going to replicate that with max salary E. Then it's going to return an either with job error and salary. And I'm going to eliminate the run catching altogether because I don't really need to throw exceptions myself or catch them. I'm going to say if this is empty, instead of throwing a no such element exception, I'm going to return a generic error, and I'm going to wrap that in a left. Otherwise, I'm going to return the salary, and I'm going to wrap that in a right. That's it. So notice how quick this thing becomes. And then I'm going to say find all E flat map, and then the function will look in a very similar way. Now, in this case, we don't really need the Elvis operator to return a default value because the generic error short circuits everything. So I'm simply going to remove this statement. I'm going to call this maybe job actual job because this is a job. It's not a nullable thing. So I'm going to say job salary value. That's it. So now we have a job without a question mark, and we are going to return an either with job error on the left and something else on the right. Okay, so the structure is very similar. So get salary gap versus max. This has the same flat map map chain as we had with results previously. So the thinking pattern is the same. Notice that this thing occurs quite often in functional programming. Again, the Kotlin language doesn't have for comprehensions to chain flap maps and maps. In Scala, that would have looked very easily something like this. We have a for comprehension where we have the job as jobs, find by IDE, and so on and so forth. Then we had the job list as jobs all. So jobs all E, find all E. And then we would have the max salary as job list max salary E. And then I would simply yield. So I would do something like this, yield max salary minus job salary, something like this. So notice how easy the for comprehension reads. Just find by ID, find all, return the max salary, and then after you have all the values, just return the final expression that you're looking for. But Kotlin doesn't have that, which means that we also need to rely on the arrow library to run a very similar eager function scope as we did for results. So I'm going to run another function. So I'm going to say get salary gap versus max. I'm going to have arrow E with job ID, job ID. This is going to return an either with job error and double for the desired result. Then I'm going to have either.eager. So notice that the scopes look very similar. So we had the result eager earlier. Now we have either.eager, and we have the same pattern. So here for the result type, we have maybe job, ensured not null, get the salary, find all, find max salary, and then return the final expression that we were looking for. Actually, I'm going to copy all of this just to show you how similar the pattern is. So I'm going to have maybe job, jobs find by ID E with the either, then I'm going to call bind. And this is not nullable, which means that this ensured not null is no longer necessary. Then we have maybe job.salary. The null is eliminated because we don't really have that nullable here in the type. Then I'm going to call find all with an E that's going to be an either, max salary E, and then we're going to return the final expression as before. So the imperative style inside this either.eager scope looks very similar to the for comprehension in Scala, but we need some construct and we need the bind functions being applied to all the either types that we cared about. So you need to be careful with these ones. So let's actually test them. So get salary gap versus max E and arrow E. So let's go back to main. Let's have print line salary gap either, and this is going to be salary gap result. Okay, and after the either thing, I'm going to have my salary gap E as job service, get salary gap versus max E with job ID 42. And then I'm going to have my salary gap E version 2 with the eager scope. So I'm going to have max arrow E. And then I'm going to also fold these. So the fold function also exists on the either type as well. So I am going to call fold. I'm going to say salary gap E fold with salary gap and error in case we have an undesirable value, as well as salary gap E version 2. So I don't know where that thing came from. I'm going to copy this, and then I'm going to use salary gap E version 2. Let's run the application and let's see our final results and maybe fix any errors along the way. All right, so we have salary gap either. We have job not found error with the job ID value 42. We have the exact same error in both cases. The funny part is that the fold takes the error thing first. So we need to swap these. So we have the error first and the salary gap second, unlike the result. So we need to swap these statements around so that we can actually print the correct value with the correct meaning. So we have the error, job not found error, job ID, and so on and so forth. If the ID exists, in our case, let's pick the number 2, we are going to return an actual salary gap. Let's see. We have salary gap 1.0 in both cases. And that, folks, was a long-form tutorial on the essential skills of working with result and the either type in a functional way, in an idiomatic way with Kotlin. I hope you enjoyed this video and found it valuable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel. For more videos like this, check me out on Twitter and LinkedIn. I post fresh updates on upcoming material. And check my website at rockthejvm.com. I have hundreds of hours of everything in the JVM world, Scala, Kotlin, and so on and so forth. Until next time, folks, this is Daniel signing off.